Hi everyone, in today's video we will solve this C program. The output of this program is just if I click here, the output of this program is just 10. The reason why it is 10, because what happens, 10.5 is float value or floating point value. When we are trying to store this value in an integer variable, uh, we see that 0.5 is getting removed because of the typecasting. In C we have a typecasting when we convert one type of variable to another type of variable. So here that is what happening here, and we will learn few more interesting thing about by making changes to this program. Before that, let me run this program on Linux operating system. I have copied it and I'm connected to my Linux virtual machine, and let's create a file. I'm just deleting if I have anything here in this directory. Okay, I will create one file main.c, and I'll press I so that I can start type, or I can paste here the code which I have copied. I'll do right click on mouse and just say okay, so I can see program here. But before running, we are just using printf. So for printf we have to make sure the correct header file is included, otherwise you will get compilation error. So the header file is stdio.h. Let's run this program and check the behavior. So to save it, I press escape shift semicolon wq. Let's run. Before running, we have to compile it. So this is the basic command, and if you want to specify a particular binary name, then I have to use -o flag, and I can specify some binary name. It can be any name or any extension. I will just call it main.out for now. So once I press enter, I don't see any warning, no errors. That means it has been compiled successfully. Now to make sure we have this binary file, I can check the content of this directory. In this directory we have this file main.out. This is one older file. Let me delete it from previous compilation. So we have main.out, which is the one which we have recently created by compiling main.c. And if I want to make sure, and if I want to check whether this is binary or something else, I can make use of file command and check. So when I run this command, I get some message like executable. This is how we can check whether this is binary or something else. And I can see here, and this is 64-bit binary because we compile it using 64-bit compiler. If you want to compile it using 32-bit compiler, you have to make use of -m32 flag. On that topic there is a separate video, and so we'll move forward. If I run this program, I see this is 10. It's just printing 10. So as I was telling earlier, it will print just 10. Let's go back to the program, and for the better visibility, just add a slash in here so that it is not, so that it cannot be mixed with the console messages. And so let's discuss this. Enable the line number first. So at line number 5 we are initializing a variable a with 10.5, but 10.5 is floating point value, but a is integer. So what happens, C will internally do a typecasting and it will convert this into 10 only. So a will store 10, and at line number we are printing the value of a. That's why we are getting C. But if I do something like this, if I change this value, if I change the data type of this value to float and convert this to, now a is float, so if I want to use the access specify float, then for that we have to use %f. So let's save this and compile this program one more time and see what it prints. It has been compiled successfully. Now I will run this program. You see here it is printing the correct value, but it is using extra zeros. That is because by default will print, it will be like after decimal it will print 6 value, up to 6 digit it will print. So to fix that, if in case if I want to just print after decimal, if I just want to print 2 value, for that we use dot 2. I'll go in insert mode, dot 2, and let's save it and run it. Before running, let's compile it again. So what is the issue here? Warning, it is giving warning. Looks like there's some typo. Oh, this is what I pressed 2 times by mistake. So I'll compile it one more time. I don't see any error, neither warning. I will run it again. You see here it is, now it is printing. So you can use, if you are using %f, and if you want to specify how many digits you want to print after decimal point, then you can use this dot 2 before f. Now one more interesting thing, let's assume the a variable is float data type, but I'm using %d here. So what I'm trying to print is, I'm trying to print integer value of float variable. In that case, what will happen is, if I compile and run, we'll get some garbage value, and that is not the right practice. Let me compile it one more time. So you'll get the warning as well, and if I ignore the warning and run this program again, you see here it is printing some garbage value. So if you're getting some warning in the program, you should first fix it. So I'll change it back to %f or point to %f. So that is the right way. So this is what I wanted to show you in this video. Let me save this file, and I'll stop here. Thanks for watching.